Today we're going to look at this Class D amplifier here. The model of this amplifier is L30D. This board is made by LJM. It's here, LJM. This board requires a dual 75 volts power supply. You can see it here. The negative 75 volts go to this connector here, and the positive goes to this another connector here, and this is the ground, and we have our output here. This board is really well made. We have some film capacitors here, all film capacitors, and it looks like we have some X2 capacitor here, this yellow one, and I think this poly capacitor, polypropylene, I'm not sure. This is our input here, so this is our input signal. Let's look at the weight of this board. It's around 365 grams. Let's look at the dimension of the board. So the length of this board is around 110 mm, and on this side 75 mm. So the height of this, including this heatsink, so the height tolerance is about 75.5 mm. Let's look at the filter capacitor. We have some 100 volts, 820 microfarad, two of them, and we have a chunky coil here with a heatsink on top. I have ordered a dual 75 volts power supply to test this board, because I currently do not have a dual 75 volts power supply, so I have ordered that one. It will probably get here in around 2 weeks. By then we're going to test this Class D amplifier. I've also ordered a a dummy load for 2 ohms, because I only have this one, and this is only rated for 500 watts, and this one is too low for this board. Okay, so this board is rated at 300 watts at 8 ohms, 600 watts at 4 ohms, and 850 watts at 2 ohms. As I have mentioned, I'll be testing this board when the power supply and the dummy load arrive. The power supply has arrived, but unfortunately the seller has sent me a dual 70 volts power supply instead of a dual 75 volts power supply. So this is what we're going to use today. It's going to take a long time to return this and get the correct power supply, so we'll be using this for today. And this is our ambient room temperature. It's around 19 degrees centigrade. So let's check our power supply first. Turn it on. Okay, that's around 70 volts on the negative rail, another 70 on the positive rail, and we have around 140 volts from the negative to the positive rail. We have our ultra low noise 1 kHz oscillator here. It's already fed to the input of our amplifier here. This is the output of the amplifier, the pink cable on this one. So the output goes to our 8 ohms dummy load here. This is our 8 ohms dummy load. It's connected here and here. And this is the probe for our oscilloscope. So we have around 40 volts peak to peak output from the amp. As you can see here, our THD meter. THD meter can lock to the 1 kHz signal. That's usually happen if there's a lot of noise from the 1 kHz input signal. If we look here, the sine wave is a little too fat. Now we're going to zoom in at the signal. First I'm going to pause this one here, pause, and then we're going to zoom at the signal here to look why the sine wave is a little fat. So in order for us to zoom in, I'm going to use this horizontal control here. Now we can see why the signal is a little too fat, because the switching frequency of the amp is superimposed to our signal here. You can see it more better here. The sine wave looks really bad. So this amp, even with low output power, has a pretty high distortion. I would not recommend this amp for high fidelity listening. Maybe this is good for the subwoofer amp. Okay, let's measure the continue and let's measure the maximum power output of this amp at 8 ohms load. So we're clipping. This is so strict. Okay, so I'm going to reduce the input of the amp a little bit to remove the clipping. Okay, so now let's look at our THD. That is maximum voltage output, 148 volts peak to peak at 8 ohms load. Look at our THD. We're at the 3% range. That's around 2.6% THD. Okay, now I'm going to change the dummy load to 6 ohms and then we'll continue our test. This is our 6 ohms dummy load. Okay, we have around 50 volts peak to peak with 6 ohm, without 6 ohms dummy load. Now I'm going to increase the output of the amp now. Okay, it's clipping at 148. That's around, it's good at up to 148 volts peak to peak, but you really have a lot of noise. Let's look at the THD. 3% load, so it's around a little bit lower, 2.5% instead of 2.6%. That's 3% range. Next is our 4 ohms dummy load. That is our 4 ohms dummy load. Okay, let's turn this off first. Now unplug this. It's pretty hot. Now our 4 ohms dummy load is ready. Let's turn it on. We have around 62 volts peak to peak output. Now I'm going to increase the input of the amp. It's clipping. Okay, that looks good. Around 144 volts peak to peak, 146. We're going to take the median at 144 volts peak to peak. Now let's look at the THD. The THD is pretty stable, around 2.6%. I'm going to hook up our 2 ohms dummy load. This is another 4 ohms dummy load here. So we are going to parallel this to 4 ohms dummy load to get a 2 ohms dummy load. Let's turn it on. So we have around 28 volts output. Okay, I'm going to adjust the output. This is 2 ohms dummy load. Okay, the amp is turning off. Looks like the amp is not stable at 2 ohms dummy load. Okay, so let's look at the maximum power output before the amp is turning off. Okay, turn off at 100 volts. Okay, it's turning off. The scope is very slow to update. Okay, the amp completely turned off now. There's no power light on the amp. So ito again. So it looks like the power supply actually died. So there is no output on the power supply. There's no output. We have one output at the low voltage rail, but we don't have one output at the high voltage rail. That's millivolt. So looks like the power supply gave up. I will retest this amplifier board when I get a more powerful power supply next time. So let's look at the result of the let's look at the result of the power output of the amp at 8 ohms to 4 ohms. So that is 148 divided 2.828 inverse squared divide 8. So it's doing around 342 watts RMS. 342 watts RMS. And at 6 ohms, 148 divided 2.828 inverse squared divide 6. So it's doing around 456 watts RMS at 6 ohms. And at 4 ohms, 144 divided 0.828 inverse squared divide 4. So it's doing around 648 watts, 648 watts RMS at 4 ohms load. So I'm going to source a more powerful power supply to test this amp at 2 ohms load. So I'll make a video next time just to test this amp at 2 ohms load. Fortunately, we cannot do that this time because the power supply gave up. So next time we're going to do this. So we have 2.6% THD at 4 ohms, 2.5 at 6 ohms, and 2.6 at 8 ohms. So there's little difference between 8 ohms to 4 ohms with the Dodge THD. So So that's it for today. Thank you for watching. Please subscribe. We're going to do the 2 ohms load next time when I get a proper high power supply.